glaciers are glacial masses that cover large volumes of a continent or the entire continent. So think of Antarctica being entirely covered. Greenland is an island. It's not a continent, but the size of the ice on Greenland will give it the definition of a continental glacier because of the nature of its shape. It's not restricted to alpine areas, it's covering an entire and large landmass. So those are our two big continental glaciers that are in residence on our planet right now. We had in the last glacial epoch, which ended around 10,000 years ago, the Laurentide ice sheet, and this was part of what was called the Wisconsin glaciation. The Wisconsin glaciation included the Cordilleran ice sheet, and the Cordilleran ice sheet occupied alpine areas, so it's considered a separate feature. I want to draw your attention to this margin where two sheets then came together that formed right here, and that created some really interesting landscapes on the eastern edge of the Rocky Mountains. And I'll draw your attention to that at the very last slide in this series. You can see the edges of this glacier have what are called lobes, and those lobes are how, if you were to put your hand on some jello and it sort of blopped out, that would be sort of this area that sort of just spills out under the pressure of the weight of this accumulation zone, which is right about here over Hudson's Bay. What we've got also are ice fields, and ice fields are exceptionally large areas of continual ice that exist where once a continental glacier existed. In Patagonia, at the southern tip of South America, has what's left of a much larger ice field, but is now made up of just a couple of small fields of ice. These structures have a dome shape when there are ice fed. And so that big dome, the greatest volume of mass of ice is in the center of that dome. And as you move out towards the margins, the ice volume diminishes. We've got a zone of accumulation, which is the center, and a zone of melting, which is the edges. So we're eroding material out of the center of this glacier, and as the glacier pushes out in all sides under its own pressure, it's picking up that eroded material and depositing it out at the edge. So what you're seeing here in this sort of funky green color is a moraine, which would have been the debris field that was left behind. So we can tell the edge, the very end of where the glacier stopped growing before it started to melt back, by the last moraine or debris field that was produced. And so this would be a terminal moraine. This would have been an end moraine, and another end moraine, and another end moraine. And these subsequent end moraines are just where the glacier stopped moving backwards after a little bit of time and then reinitiated a backward retreat. A couple of other features that were left behind that are debris are eskers. These are the product of under ice rivers. So these would have been riverbeds essentially, which is kind of neat. We've got some kames and some drumlins, which are erosional features. Kettle ponds, for which Ohio has several. We know those mostly as wetlands now. This kettle ponds are where a big chunk of ice was left behind, and the weight of the ice sort of created a depression. And then once it melted away, we are left with the depression. Then we've got things like outwash plains, where this lobe would have had a river running out of it, and the river would have created a braided stream, depositing material as that water melted out. So here's these braided streams that are creating this ice wash. Here are these remnants of ice that I had mentioned that are creating these kettle lakes, kettle ponds. And so Ohio is a fantastic example of a glacially deposited landscape. All of this material is really, really kind of critical to Ohio's industrial era because we had raw material for construction and other types of industry. Really, really important. I've got a second diagram here of the Laurentide ice sheet that shows the provincial borders and the state borders to really give us an idea of how far this ice extended and the time frame for this Wisconsin glaciation, which extended from 75,000 years ago to 11,000 years ago for the most part.